Yesterday class, what we have discussed.
We saw the program for insertion at the middle and insertion at the end, ma'am.
Okay, fine. Uh, what about others? Is it clear for everyone how we can insert into the linked list at the ending position and also the middle position we have discussed, right? So today we are going to see about how we can delete the particular node in the linked list, singly linked list. How we can do. We will. Okay. Now we're going to see about deletion at the beginning in the linked list. Here also we have three more options, that is deletion at the beginning and deletion at the end and deletion in the middle of the singly linked list. Okay. So first we are going to see about deletion in the beginning of the list. How we can delete? Please, any idea, anyone? How we can delete the first element? First node in the list. Here I given some lines. Please read that and come up with idea how we can do. Go fast.
We can make the new node point to the head node, ma'am.
Mm. Once again, Santosh.
We can make the new node point to the head node.
New node pointing to the head node. Why? We are going to delete a node here.
Ma'am, we should change the head node.
Change the
Head
head node.
node.
Yes. How we can? How we can? First of all, we need to change the head node. In general, which one is the head node? In general, in the linked list, which one is the head node? Yes,
The
please. Any?
first node.
Yes, the
First node,
first.
ma'am.
Yes, very good. The first node itself, the head node in the linked list. Now I want to delete a particular node, means then I need to what? Move the head to the second node. Okay. Then after moving, I am going to delete the particular previous node, that is the first node. How we can delete means with the help of delete keyword we can delete. Okay, just pointer, that means the link is we have to make the link between the head, I mean the start pointer to the second node, and assign the second node as the head node. After that we are just removing the first node, that is a delete. Using delete keyword we can remove the first node. Okay, this is the linked list. This is the linked list. Here what I'm doing is, this is the routine for deleting at the beginning of the linked list. How we can do? First of all, I wrote one function. In that I'm giving that, just first assigning the head to the temp value, that is just this is the one temporary variable I have declared. With the help of this, just I am assigning the head node to the temporary variable. Head node means the first node in the linked list. Just assigning the first node to the temporary variable. After that, I'm going to do what? That is the second. I'm going to assign the second node as the head node. Okay, first time move the head node in general. In first case we are having the head node, the first node is the head node. Now I'm moving the first head node to the temporary variable. After that, assigning the second node as the head node, then I can remove the previous node. This is the process. This is simple process here. That is I'm declaring one temporary variable, just it's pointing to here. Why means I'm just assigning the head to the temporary variable. Okay, just assigning the head to the temporary variable. So the temporary is here, the variable is here pointing to this head node. After that, what I'm doing, what is the t of next? What is the t of next? This is the t, right? Now only I'm assigned this is the t node. What is the t of next means? Which one is the next field? This is the next field. T of next is what? 850. This is nothing but the second node, right? That is assigned to the head node. Okay, so the head is moved from first node to second node. Okay, now the head is here, t is here. Okay, is it clear, everyone? First I'm assigning the head to the temporary variable. After that, I'm fetching the second node with the help of what? T of next. With the help of T of next is 850, which is the second node. It is assigned to the head variable. And now what I'm doing? Free of T. This is a keyword which is used to delete a particular node. So free of T means which one is the T node? This is the T node. Now I'm deleting this node with the help of delete keyword. Is it clear, everyone? No, so the link is disconnected. Now I'm having this three nodes only in the linked list. Okay, is it clear? Please give me a reply. Is it okay? How we are doing deletion in the beginning?
Yes, ma'am.
Yes.
Yes,
Others?
ma'am.
Yes. Yes. Very good. Okay, pa. Thank you. Thank you for your response. Please, others also give some response. So it is the deletion at the beginning in the linked list. Then we are moving to the deletion at the end in the linked list. How we can? Any idea?
Ma'am, we should make the pointer field a null, ma'am.
Mm.
We should convert the tail
Which
node, ma'am.
which pointer node? Pointer field. Which pointer field?
The last one, ma'am.
Yes.
Second last, madam.
Yes, second last. How to make the second last pointer node as the null value? Then automatically it remove. Otherwise, we are just moving. We can move the tail node to the previous one, and with the help of delete keyword, we can remove the tail node. Okay, is it clear? The deletion operation is somewhat easy only. Just understand what is happening here. So for the routine, what is the routine means? Just I'm declared one function, define one function. In that I'm declared one another one variable, that is TP, and I'm the next line I'm assigning the head to the T. What is the head? This is the head, right? The head node is assigned to T variable until why we are starting from here?
Because we don't know which one is the tail node.
Yes, we don't know the which one is tail, and so we don't know how many elements in there. May how the list is empty. Some may how the list is empty, so that I'm come start with the head node and check the condition that T of next not equal to null. What is the T of next? Which one is T? This is the T node, right? What is the T of next? Which one is the T of next?
850, madam.
Yes, very good. This is the T of next. This is the node named as T, and this is the data field. T of data means 83. T of next means 850, which is denoting the second node. Okay, is it clear? So while T of next not equal to null, when it is equal to null, when it becomes equal to null, T of next
At the
At the
equal
end
to,
node,
tail
madam.
node.
yes, at the end, and also the tail node. So until we reach the tail node, we are doing this loop. Okay, T of next not equal to null. Here also not equal to null. Here also not equal to null. Here also not equal to null. When it reaches the tail node, then only it becomes null. Up to that, we are doing this process. What is the process? T equal to TP. What is the T node? What is the T node? Please. Which one is the T node? The first node. Just we are assigned, right? The head is assigned to T. So the head node is the T node. Now I'm assigning other one. That is that T node is assigned to some other variable that is called TP. Okay. Now I'm assigning the T node into TP. After that, I'm incrementing. That means in the case of for loop, we are giving I plus plus. In normal program, we give I plus plus or like that I minus one. Like and likewise we can give here in the case of node we do with what t equal to t of next. What is that meaning? Means t equal to t of next. Then again now the t value is here, then again I giving t equal to t of next. Okay, incrementing, moving from one node to another. Likewise we can do, this is like increment functions. Okay, t equal to t of next means incrementing one node one by one. Okay, this is the process happening here until we reach equal to null. Until we reach equal null, just we are moving, traveling through the list. T is traveling behind the t, the tp is traveling. Okay, we have two variables, one is t and one is tp. T is traveling first in the linked list. After T, once the T is assigned, after that the T is assigned to TP. Okay, just we are traveling. For that we are using two temporary variables, and when the loop is stopped means the T of next equal to null, then it comes out of the loop. Okay. When the T values first, the T in first iteration T value is here, and next the T value is here, and likewise it's incrementing. First is here, then next is here, and then next in third node likewise is moving. Finally when it is becomes here, then the t of next equal to null. Here only the condition is true, so it comes out of the loop. Okay, in that time this fourth iteration the tp is placed here in the previous node. Okay, first of all the tree only travels the linked list. After that behind the t, the tp is coming, so it is in the third node. The t is in last node and tp in third node. Okay, so the it comes out of the loop. Here what I'm doing, tp equal to tail. What is that? tp is placed here. Now the tp is placed here, so I'm assigning that TP equal to tail. Okay, the TP equal to tail. That means the previous node is assigned to tail variable. After that, what I'm doing, tail of next equal to null. Where the tail is placed now? Here only, right? The third node is placed. The tail is placed under third node. So I'm assigning tail of next equal to null. That is that. This is the null. I'm just remove the address and placed as a null value. Automatically, there is no once I'm filled with null, then automatically no link between third node and fourth node. After with the help of delete free keyword, I can free or delete keyword, we can do the what deletion operation of the particular node. Is it clear, everyone? I can free the what memory allocated for the particular node. Okay, anyone please come forward and explain again.
Ma'am, shall I, ma'am?
Yes, ma. Yes, Ramya.
Ma'am, first we are checking which one is the tail node, ma'am. For that we are using while loop, ma'am.
Okay.
How we are checking means if tail node, ma'am. So that for that we are checking that checking using while loop, ma'am. In that while loop, TP is equal to T, ma'am. We are just assuming a temporary variable TP, ma'am. First head node will be T, so that will become TP, ma'am.
Okay.
Shows that T is equal to the next node after the T, ma'am. In that
Okay.
loop, this
Okay.
process will keep on continuing, ma'am. When the condition became false, that is when the tail node is reached, then while loop will not work, ma'am.
Okay. Good.
Then it comes to the next step, ma'am. Tail will be TP, ma'am. then the tails next, that is the pointer field of the tail node will be null, ma'am. So we are deleting the last one using free, ma'am, free of the node.
Okay, fine. Thank you. Very good. Thus, if you have any doubt, please ask. No doubt, right? Shall I move on to the next one? Yes, please. Shall I move on to the next one? Yes, ma'am. Rohit only replied. Yes, Manoj.
Yes, ma'am.
Okay, fine. Yes. Okay. Okay. Next, we are going to see about deletion at the middle in the singly linked list. Here, you can anyone can tell me the idea. We are following the same procedure for a long time. That is the insertion in 3 cases and deletion in 2 cases. Already we have discussed. So you can come forward and explain what is the process, how we can delete the middle element or specified position in the singly linked list. How we can do? Anyone? If you have understood, then you can do. Please, anyone? How we can do? Any idea?
Ma'am, we should identify which node we want to delete, ma'am.
Yes.
Then we should delete the pointer field of the previous node and change it to the
Successor of deleted node. Okay.
include, ma'am.
Mm.
Then that's all, ma'am. We
Okay.
should delete the node which we don't want
Okay.
using
Okay.
free.
Okay. Fine. Thank you, Ramya. And here I'm having some lines. That is, here we make the next pointer of the node previous to the node being deleted. Here we make the next pointer of the node previous to the node being deleted. Which node we are going to delete? This is the node we are going to delete. Okay. So the previous node is this one. And the next pointer of the previous node is this one. This is the address node. That is the next pointer node. Okay. This field here, make the next pointer of the node previous to the node being deleted, point to the successor node of the node to be deleted. Point to the which one node is going to delete? This is the temp node. Which node is the successor of that particular node? That is T node. So it point to the successor node of the node to be deleted and then delete the. So it is point to this and delete the middle node. Okay, is it clear? This is the process. Just we are going to find out the position where we want to delete. Likewise, so the which node are going to delete, we are in that place. We need to know which one is the previous node and which one is the successor node of that particular deleted node. So we can give the address of D node into the B node pointer. This is the process. So this is a simple routine. Okay, first of all, we are going to what we are going to do, that is, need to check the element, which position we want to delete, or which element or which node we are going to delete. This is the process. In that time, fetch one, get the input from the user, that is the number is 70. Here this is the linked list I'm having. This is the 70 uh, data which is under the third node. Okay, this is the node I want to delete. So for that, what are the process? I'm declared one temporary variable, just assigning. How we can do means, all are come with a head node, right? With no other case we can access we can't access directly the second node or third node, and the value 70 like this we can't do. We can only start from head and travel through the list. After that only I can find out particular position and details likewise. Okay, so I start with head node. The head node is assigned to the variable t. Okay, this head node is assigned to, again it is like previous one, assigned to the variable t. Now going to the while loop. Why I am doing this, I'm going to find out the particular position, right? For that I need to travel through the list. How I can travel means, with the help of while loop I can travel through the list. Here I am giving the condition as t of next. What is the t value here? T is nothing but head. The previous line I have assigned. So the t of next, that is, this is the head, this is assigned to t value. So this t is t of next. That means the t of next. What is the t of next? This is the t of next, right? That's this t of next not equal to num. Num is nothing but the value which is given by the user, that is 70, not equal to num. Until equal to num, it's this loop is keep on moving towards the right. Okay, once it reaches the data value is equal to 70, then it comes out of the loop. Again here also I'm doing the same process. The t is assigned to tp and t is moving each and every node. That is, it is like increment. The t equal to t of next, that is nothing but t equal to t of next. That then again t is moved here, the second node, and t equal to t of next means this is the pointer node. The next one is here. Likewise, the t equal to t of next is nothing but it is like incrementing by one node. This is the process. Once the loop is once the condition is false, then it comes out of the loop. That is, I'm doing what, t of next is assigned to tp of next. Now I'm checking the value. This is the condition not equal to 70, so the condition is true. The while loop is executing. Here the condition is false, so it comes out of the loop. The t value is here, so the t of next is assigned to tp of next. Tp is here, t is here. Okay, in this iteration, sorry, in this iteration the t is here and tp is in the second node. First the t node will traveling the list, after that began the after the t only the tp will come. So this is the t placed in sorry, t is assigned to the particular third node. So I'm assigning the t of next. What is the t of next? This is the t of next, right? This is the address of next node which is assigned to the tp of next. What is tp of next? This is the tp of next. So this address, that means the 1500, which is the address of the next node, right? This is assigned to the previous one. Okay, now it's clear. Now the process is over. Okay, so no link between here and the second node and the third node, because I'm removing the address of the third node and replaced by the fourth node. So it is directly linked to the fourth node. Now the link, that means the node is not in the linked list, so I can free that particular node. Okay, this is the process in the, we can delete the particular node in the middle. Is it clear, everyone? So far we have come up with what is that, deletion in the beginning and beginning and end, and so middle. Okay, is it clear, everyone? Any doubt? Any doubt? Okay, any doubt? Shall I move on to the next one? Yes. Yes, Yashvin is asked, using for loop, ma'am. Using for loop, ma'am. Yes, you can. This is the logic I have explained. You can do with more other ways. Okay, some other ways are there. For example, if I'm going to delete an element in the beginning, right? Just I'm using here, what is that? free of that is the keyword. Without this keyword I can do. How I can means, just I'm giving just assigning the head to the next node, and make this node as a null. With the help of this I can do, right? Now the linked list is start from here, no connection between the first node and second node. Likewise we have many other ways you can do with any other loop, and you can do, but the output is what we want. Likewise we can do with any other ways. Okay, Yashmin, let's go. Okay, and Nitish Kumar ma'am, can you once again repeat ma'am? Yes. Okay, good. Nitish Kumar, which part pa? All the three are which one I want to repeat? Yes, Nitish, middle. Okay, no problem. Just I'm traveling through the list. Okay, I want to delete a particular node in the middle of the linked list. How can I find? Mean the user may give some position or some values with the help of this. I mean, this the main motive is nothing but we can delete any node. It means a specified location. How to find out the specified location, then we go for deleting a particular node. Okay, so that I'm asked user the value which one you want to delete. Likewise I can ask, that is the user here assume that is the 70. This is the linked list I'm having. How this is the third node, the 70 is nothing but the third node we want to delete. Okay, so how we can achieve that particular third node means we can't directly access this is the disadvantage in linked list. We can't directly access the any specified node or value anything. In the case of array we can do, right? How we can fetch the how we can fetch the data in array in a specific location? How we can?
Using index, madam.
Yes, with the help of index we can do. That means I can, if I want a of 3 means I can directly the position a of 3 I can fetch the data. But in the case of linked list we can't go for that option. Just we can go with the head only. That means the starting node only we can travel through the list and find out the position. So that I'm start with the head node. Okay, in head node I'm starting here. So the head is assigned to t, the variable t. I have one variable t and another one, the structure variable is the tp. I have two variables here. First assigning the head value to the t, that means the temporary variable. Okay, the head is assigned to t. So what is the name of particular first node now assigned? That is the t. Okay, now the t, the first node is called as t. So t of data is nothing but 83. T of next is nothing but 850. Okay, so here I am coming to loop, while loop. In this while loop I'm just sorry, what checking one condition which is nothing but t of data not equal to num. Now the t is placed in first node, right? I'm going to check t of data. What is the t of data? Nothing but t of data. What is that? This is the t node. Then what is the t of data? Yes. What is the t of data? T is assigned to the first node. What is the t of data? Without knowing this, I can't go further. Please, anyone.
83, ma'am.
83,
Yes.
ma'am.
Okay, fine. 83. Okay, pa. Thank you. So T of data is nothing but 83. Okay. I'm checking T of data not equal to num. What is the num value here? 70. So 83 is not equal to 70. This is the condition I'm going to check. Okay, 83 is not equal to 70. This is the condition I'm going to check. It is true or not? It is true or not? Yes.
True, ma'am.
Yes, it
True,
is
ma'am.
true, right? When it becomes false, when it becomes
70 is not equal to 70.
what?
equal
17
to
is not
17.
equal to 17.
Yes. When both the elements are both the values are equal, then it becomes false, right? When it will happen, when it becomes when we are find out the particular element, then only it becomes false, right? So we are moving from head to through the list. Start with the head node and checking the value t of next not equal to num. Yes, t of next is not equal to num. The condition is true. So I'm doing what? If the condition is true, then inside the loop will execute, right? Is it clear? When the condition is true, the loop inside the loop is will execute. If the condition is false, then it comes out of that loop. Okay, is it clear? This is an important point. Once the here the condition is true, so what will be the process? The t is assigned to tp. Where is the t? The first node. Now the t is in first node. The first node is assigned to tp variable. Now the tp variable having the node which is under tp. Okay, sorry, t. The node is the t node is assigned to tp. Now this is the process. So t is assigned to tp. Again, next step I'm doing, this is called incrementing. Okay, increment, we can increment by in normal cases we are doing I plus plus or I plus 1 or like I equal to I plus 2. Likewise we are incrementing. Here I'm doing increment with the help of t of next. Do increment by one node. So t equal to t of next. What is the t of next here? What is the t of next? This is the t of next. This is assigned to what? T. T of next is 850. This is what? The second node. The second node is assigned to t. So the t is comes here. Okay. This the second node is named as t. And what is the name of first node? Now, what is the name of first node?
TP.
TP. Very good. So the first name is named as TP and the second node is named as T. Okay. Likewise, we are incrementing, we are doing the same process towards the right when we are reaching the particular specific location. Okay. So in next iteration, the T is comes here. Okay. The TP is comes here. Okay. The second node is assigned to TP and third node is becomes T. At that position the condition is false, so it comes out of the loop. The t of next, so now the t values were, this is a t is assigned to the third node, the tp is in second node, the t of next is nothing but the address of fourth node. This is assigned to what? TP of next. This is assigned to TP is placed where? The second node. The second node is named as TP. The third node is named as T. So the address of T node is assigned to TP of particular node. So the 2800 is replaced by 1500. Okay. So there is no connection. No other node having the address of particular third node. Okay, so the connection is dropped here. So we can delete the particular, free up the memory by free of t. Is it clear, Nitish?
Yes, ma'am.
Okay, fine. Can we reverse the iteration in SSL, ma'am, in both deletion and insertion? Can we reverse means shall we start from tail node? Likewise, you are asking Sandeep.
Yes, ma'am.
Yes, yes, we can do. I'm not clear. I will check. I will check and give your explanation on tomorrow. Okay. I don't know clearly, but we can do right. With the case of accessing the, if accessing the tail node, then we can do the process, right?
There won't be any connection, no, ma'am. Only the before only will have the pointer, no, ma'am.
Yes, yes, very good. Before only we are in the case of a doubly linked list, we can do. We
Yes,
are
ma'am.
have
He's asking a single, no, ma'am.
yes, very good, pa. Okay, so we can't no, we can't move from tail to head. Sandeep. We
It is
can,
only possible in the double and circular only, no, ma'am.
yes, I think so. Because in tail node we are not having the address of previous one or next one. This is tail node is the last one and don't have any address or don't point to any other node. So we can travel the list with the help of head only. We can travel, yeah, because here only we are having the address of another one, and in that we are having the another one. Likewise, with the help of head only we can do. Okay.
Okay, ma'am. Thank you.
Okay, okay, fine. So the next one is searching a element in the singly linked list. How we can search? In previous class also somebody said, what are the way we can search?
Binary search.
Yes, binary search. Another one,
Linear search.
linear search. Okay, which one is best for linked list? Yes, which one is we can go with the binary search or linear search in the case of linked list? Which one is best?
Linear search, madam.
Linear search. Why?
Because in binary search, we start from the middle and go, we keep shrinking the borders, madam. But here, since all the nodes are assigned in random locations, we can't do that, madam.
Okay, okay, fine. Very good,
We have
Santosh.
to start from the head node and move on.
Yes, yes, very good. That's why we are in the case of searching, we have two ways. One is binary search, one is linear search. So what does mean by binary search? Just we are taking all the elements and divide them and searching after the dividing, dividing, and so we come up with the element. Okay, this is the process in binary search. In the case of linear search, what is the process? We are taking one element and check and move on to the next one, next one, like this. So taking each and every one by first node towards the number of elements, going searching and find out that this is the linear search. And in the case of linked list, we can't access randomly any element. So we are come up with a linear search. In the case of binary search, we need to find out the middle portion and divide them. This is not possible in the linked list. So we are come up with a linear search, which linear search is the best for linked list. Okay. Searching involves finding the required element in the list. We can use various techniques of searching, linear and binary, and were binary more efficient in case of arrays. In the case of array, we have no, right? How many elements in the array? We have no. And after that we can divide and search with the help of binary search. But in the case of linked list, random access is not available. It will become more complex to do binary search. So we can come up with a linear search traversal. How we can do? How we can search a particular element? Already it is related to the previous one, deletion at the middle. So any idea how we can search a element? Anyone in the linked list? How we can do?
We will start from the head node, madam, and compare the data in head node, data in each node with the key value. If it matches, we return
Okay,
the
fine.
location.
How we can compare?
Using equality
While
of
loop.
Okay, fine. Uh, the which value we are going to find the search, that value is compared with the each and every data in the node. Once it reaches the particular when the condition becomes equal to that particular element, then we can return the particular data. Otherwise it moves on to the next one. Likewise we are going to do. This is the process routine for search element in the linked list. First designing, you start from head node. Head is assigned to t. That's a variable, and again I am checking the t not equal to here. What is the process? What's the use of this symbol? Yes, what is the use of this symbol?
and operator, ma'am.
Why we are using?
We are checking both the
Both of
conditions. If both the conditions are true, the loop will exit, ma'am. If both
Yes,
the conditions are false, the loop will exit.
yes. Once we are going with more than one condition, then we have to do we have to go with this particular symbol. Okay, I have to check more than one condition. That means the t not equal to null. What is the t now? What is the t?
Head, ma'am.
Head. So how to check the head not equal to null, and so t of data not equal to num. What is the num value here? 9. Okay, this is a 9. So I have to check with two condition. Now the head is assigned to t. I have to check the t not equal to null. This is the linked list I'm having. Head is here, so I'm assigning the t to head. That means head node is assigned to the variable t. Now I'm checking what is t not equal to null. Particular t means what is that? The first node. This is not equal to null. Yes, this is not equal to null. Okay, the condition is true. Okay, when it becomes false, it is equal to null, then it becomes false. Now it is true, the t is not equal to null. And again the next condition is t of data not equal to num. What is the t of data here?
83.
83. Very good, very good. This is the t of data, right? This t of data is checked with what is the number, what is the element we are going to search. This is the
9.
9. Okay, so now I'm going to check with 83 is not equal to 9. Is it true? Yes, right? This is also true. So when the both the conditions are true, then I go with one line. That is inside the loop I have wrote one line. What is that? T equal to t of next. Now the which one is the place of t? Which is the t node now?
Second node.
First node. Now I'm here only. Okay, pa. Now I'm here only. I'm doing what is that? T of next equal to t. What is the t of next? T of data is 83. T of next means
Pointer.
yes, pointer. That is the 850. Okay, this is the t of next. This t of is next is assigned to what? T value. That is t of next having the address position, not a value. So this address is pointed to the another node, that is the second node. So what's the meaning? The second node is assigned to what? The t. Okay, is it clear everyone? The t of next is assigned to t. What is the value in t of next? That is 850, which is not the value, it is the address. So it is pointing to the second node. So the whole second node is assigned to what? T. Likewise, we are moving. Now I move from the second, in first iteration, I'm the t value is in head node. Now the here the t value, that means the t variable is comes to the second node. Okay, now the position of t is second node. I come up again, I checking the condition and doing the same process. Again I'm coming to check the condition. What is that? Now the position of t is second node. T not equal to null. Here also what is that? T not equal to null, right? The condition is what? True. Again I check with another one condition I'm having, that is data. T of data not equal to num. What is the t of data now? What is the t of data? T of data. Which one is
9.
9? Very good. Yes, good. This is the T of data. Now I'm checked with the T of data with num. Num also, what is that? 9. So the condition is false. So I come out of that particular loop. Again, here I'm doing what? Return T. Now the T value is returned. Okay. Okay, is it clear? This is a process. In this way, we are going to search a particular element in the linked list. Is it clear why I am giving so much of explanation in a singly linked list? Singly linked list means then it is same as the same process will repeat in the doubly linked list and circular linked list. Okay, once you have come up with clear idea about SLL, then you can easily go with DLL and CLL. here that in DLL and CLL also we are going to do the same process, but some changes. What is that? In the case of DLL, we having to another one field is also there. In the case of single linked list, we are having two fields. One is the data, another one is the pointer. In the case of DLL, we having two address field. That is one data field. One is the previous pointer, next one is the next pointer. Okay, so two pointers and one data in the DLL. The remaining process are same as like the SLL. Okay, okay, fine. Is it clear so far what we have discussed? Now I have come up ended some process, that is the operations I have ended. This is not in our time point. Anyway, without we are doing so far we have discussed the operations in the linked list. This is nothing but this is a routine for create a linked list. Okay, once we are created, then only we can do. Once we created only, then we can do the what operations, insertion, deletion, everything, and so the count and runs. Okay, fine. Before going to that, I have come up with some MCQs. Please, we can discuss and give the answers. Which of the first one is which of the following is not a disadvantage to the usage of array? Not a disadvantage. Anyone, please?
D, ma'am.
What?
D. C, ma'am.
D.
I need more answers, please. I'm giving. I'm come up with the MCQ. I means it is somewhat relax or need to avoid boring. Okay, so please answer everyone. What is the answer of first one? First question. Which of the
Option C,
following?
ma'am.
Option C.
C, ma'am.
Uh,
C.
C, ma'am.
okay. Okay. Any other answers? I'm audible.
Yes, ma'am.
Okay. What about my screen? My screen is visible.
Yes, ma'am.
Yes, ma'am.
Okay. Okay. Fine. Fine. Then tell me. Answer. Most of them said C. Any other options? That is A, B, D. Anyone? Only one
D, ma'am.
person. D. Who's
Mm.
that?
D, ma'am.
Yashvin, ma'am.
Yashvin. Okay. And Manoj also said D, right?
Yes, ma'am.
Okay, fine. Any other answers, please? Girls, other than Ramya, please. Girls, yes. Otherwise, I will point out. No other go. Which of the following is not a disadvantage to the usage of array? Not a disadvantage. First of all, we have to know what are the advantages of array. Okay, then only we can find out the disadvantage. Any other options? Any other answers, please? Any other answers, boys? Yes, Mohit, option D. Okay, any other answer? Boys? Yes, Abhishek, C. Okay,
Ma'am, C,
who's that?
ma'am. Hi, Sylvia.
Sai Sylvia. What is the answer, ma? C.
C, ma'am.
But the correct answer is D. Some people said, right? This is the correct answer. Okay. Which of the following is not a disadvantage? First of all, we have to know what is the what are the advantages of sorry, Okay, the accessing elements at specific position is not a disadvantage for array. It is a disadvantage for what? Accessing
List, ma'am.
element list. Okay, this is the answer. In the case of list, accessing elements at a specific position is a disadvantage. We can't do with we can't randomly access any element in the list. But in the case of we can do so. This is not a disadvantage. Okay, is it clear, everyone? Okay, the next one. What is the time complexity to count the number of elements in the linked list? Any idea, please?
B, ma'am.
B, ma'am.
B.
Option B, ma'am.
Okay. Okay. Any other answer? Yes, Predashni and Pavitra said B. Yes, Venkata Sai. Yes, Rubaina, Sharon, Sandeep. All are said B. Yes, this is the answer. How? How you find? Please, anyone?
Because to count we use only one for loop, ma'am.
Yes, for count we are using only one for loop, and with the help of for this we are iterating n times, that is n number of times. So the answer is order of n. Very good, thank you. And the next question. Set no setting. Okay. Try to find out the answer. What is the functionality of the following code? Is it visible to everyone? What's the time? 10 o'clock. I have to wind up by 10, right? So, okay, we will discuss the next one in next class. Pa. Okay, this is the routine for creating a single linked list. Okay, how we can do? Any idea? First, go through this code and then come up with the idea. Routine for create a linked list. We are did so many operation in the linked list. First of all, we need to create a linked list, right? So that I come up with this routine. Please give some idea. First of all, in first line, I'm just read one by one line. You only come up with the answer. Okay, please come forward to answer this. I explained so many routines, so you can, I think so. So this is the first line, which is used for what? Why we are using this, please?
To create a node, madam.
Yes, to create a node and
Memory
also
location.
memory location. That means for a particular node,
Allocation.
we are assigning or allocating some memory in the system. This is the first line, which is used for what? That only the node n is created, right? So the next line is for what? Yes, scanf. Yes, come forward.
Asking
Yes,
the data, ma'am.
asking the data. Now I'm created the node. In that I have to fill the data and so the address. So that I'm asking one value from the user that is assigned to what? Where n of data. Okay. Now I come up with one node is created. The name of the node is n. In that I have two fields. One is data and one is address. Now I ask the address from data from the user, that is under value. This value is assigned to what? N of data. This is the n of data. For example, I am giving 5 means that is stored under n of data. Okay. Now the value is inserted. What is the next line? Please do fast. What is the next line? N of next equal to null. What is that?
It represents the tail node, ma'am.
uh, no need to think because just creating the n node. In that I'm filling the value of data. Now n of next equal to null. N of next is nothing but this is the n node. N of next is this is that. Now I'm assigning this is the null node. Just I'm going to now only I'm going to create. So this is the head node, this is the tail node, right? So I'm creating the node with node name of the node is n, and having the value of, that is the data is 5, and the pointer field is null. Okay, so far it is clear, everyone? Yes, give me a response.
Yes,
Yes.
Okay, fine.
Yes, ma'am.
Okay, okay. Yes, yes, fine. Thank you. So the next I am coming with the if loop. What is the process here? Head equal to null. What is the checking? What is the condition? What will be the output? Why we are doing this? Anyone?
To check whether it's the first node.
What pa?
To check whether it is the first node, madam.
Whether it is first node, and so we can say like whether the linked list having some nodes or not. Okay, if the head equal to null means what is the meaning? There is no node in the list. Is it right? Yes. Is it right? If the head is equal to null means, head means not the address value, just node of the name of the particular node. The head node is equal to null means no other node, no more nodes in the linked list. Just the linked list is empty. Okay, this is the meaning for that. So if I'm checking whether the list is empty or not. Now only we are going to create. So it should be in empty. Okay, it should be the linked list. It should be empty. So it is empty means what is that I'm doing here? Please, anyone do fast. What is the meaning of head equal to n and n equal tail equal to n? Is now I'm told that is this condition is used for checking the whether checking the particular linked list is empty or not. Head equal null. In the initial stage, it should be null. It should be true. That is the head equal null. So I'm doing what?
naming the head and
Yes.
the tail node as n, ma'am.
Yes. What is the n node here?
The node which we have created.
Yes, the node which we have created is the only one node in the list. Now I'm checking the list is empty or not with the help of head equal null. Initially it should be null only. So the condition is true. So that it becomes to the inner portion of the loop, that is the particular node which we have created. That is only the head. That is only the tail. The only one node is in the linked list. Now I have inserted. So this is the head node. This is also the tail node. Is it clear, everyone, so far? Is it clear up to this? Is it clear? Please give me a response.
Yes.
Unmute and speak. Yes, ma'am. Okay, okay, fine. Okay, pa. If it is not in the case, that means if it is for this loop is for what? Checking the particular linked list empty or not. If it is empty, the newly added node will be the head and also the tail. Otherwise, some nodes are in the list. For that we are doing what? For that we are doing what? If you able to following me?
Yes, ma'am. We are just putting that a pointer field of the tail node to the next node what we have created, ma'am.
Yes, very good. The newly created node is assigned to the tail of previous node. Okay, and newly added node is the second line. What? The newly added node is it becomes as tail. Okay, is it clear? So for I have completed. That is, again I have some other line which is used for inserting some more nodes. If printf, that is why is it is for continue, and next I'm uh, it fetching the input. In the case of character, if it is while if it is a yes means, again I am doing the same process. Okay, okay, this is the routine for creating a linked list. Don't be simple. See this, you try in your home. You please try this and come up with some more explanation. Okay, this is the process happening in creating a linked list. Please try. Next one is routine for count the nodes in the simply linked list. How we can count the nodes? Yes. Yes, Santosh. How we can count the particular nodes in the simply linked list?
We'll create a temporary node, madam, and
Okay.
we'll assign it to each values in the node, madam.
Temporary node.
Yes, madam.
Yes.
So if it point if it the next if the next pointer points to null, we'll exit the loop, madam. Else we'll increase the counter variable, madam.
Okay, fine. Yes, please, Ramya, can you?
I have a doubt, ma'am.
Whether
Yes, who's there?
Where Mohammed Yashin, ma'am.
Tell me, Ashwin.
Are we creating a node or we are assigning head as a temporary variable, ma'am?
Just assigning the head as temporary. We are just going to count the particular nodes in the linked list. We are having linked list. Okay, in that we are going to count how many nodes are in the list. Likewise, we are going to count. So first, I am declaring one temp variable. Okay, in that I am assigning the head as everything. Every process is start with a head node. So that I am start with head. That head node is assigned to temp variable. With the help of this, I'm going to check the process. Okay, is it clear, Yasmin?
Yes, ma'am.
Okay, fine. Yes, Ramya, please.
yes, ma'am. First, we are declaring count is equal to 0, ma'am.
Yes.
We are declaring the temp variable has the head node, ma'am. First, we are checking whether the head
Why we are
node.
start from head node?
Ma'am, actually, your voice is breaking, ma'am.
Why we are start from head node?
Ma'am, because we want to count how many nodes, ma'am. We are checking that head node pointer field is null.
Yes. Pointer field is null.
We are
Ramya?
Ma'am, actually, your voice is breaking for me, ma'am. I think I have poor network connection, ma'am. I'll
Yes,
rejoin,
yes, yes.
ma'am.
Your voice only breaking. So, okay. Now I'm declaring the count variable. In that time is over, right? Assign the head to temp variable. Just checking the temp is not equal to null. That means then not empty. Then count value is incremented. Otherwise, it comes out of the loop. That is all about the count. Counting the number of nodes in the list. Okay. Is it clear, everyone? That's all about linked list. Only one slide is that is advantage and disadvantage. We will discuss in the next class. Yes. Shall I stop here? June is the next hour.
Myself, madam.
Okay, ma'am. Okay.
Yes.
Uh,
Yes, ma'am.
Thank you, students. Thank you for your response. Please try this code in your home also. Then come up with a more clear idea about SLL. Okay, fine. Thank you so much. Thank you, students.
Thank you,
We'll
ma'am.
see. Okay, fine. Thank you.